Hello everyone, myself D. Sridashni from final year IT and my teammates are Niveta and Janajosa, and our final year project is enhancing and empowering the visually impaired using a IoT based smart stick. So the main aim of the project is to develop a smart stick that overcomes most of the problems faced by the visually impaired people. So the main objectives are to recognize objects and currency with the help of a deep learning algorithm, to detect the obstacles faced in the day-to-day life of the visually impaired people, to monitor the pulse rate, to check with surfaces, to send emergency notifications and current location to the caretakers, to identify the activities of the humans. So we have used the Raspberry Pi for the projects because it is low cost and it has the huge processing power in a compact board and it has many interfaces and it supports Linux and Python. The cost estimation of the project is around 14,000. The idea generation for the project is the main modules are obstacle detection, object recognition, currency recognition, water detection, health monitoring, GPS monitoring and GSM module. So we can improve the revised design of the project by adding GPUs to the project to increase the speed of the project, and we can incorporate advanced sensors like infrared sensors instead of ultrasonic sensors, and we can consider the cost effectiveness by reducing the cost of the project. The procedures or tools we have used for the project includes Raspberry OS, Arduino IDE, Android Studio and Firebase. The model or prototype of the product consists of a Raspberry Pi integrated with ultrasonic sensor, horn, camera, clock, light, water sensor, GSM, GPS and a heartbeat sensor. The currency recognition module identifies the currencies placed in front of the Raspberry Pi camera, which is trained using the MobileNet V2 algorithm, and it identifies whether the placed note is 500 rupees or 200 rupees in front of the camera. The object recognition is used to identify the objects placed in front of the Raspberry Pi camera, which is found using the TensorFlow Lite model, YOLO model and object, and it is trained using the COCO model dataset, which consists of 80 objects with more than thousands of images trained. And the activity recognition for humans model identifies the humans present in front of the camera module and identifies whether the person is standing, walking, sitting or saying hello, etc. by identifying the skeleton structure of the humans. Obstacle detection in this module we have used ultrasonic sensors which are placed in front, left and right, and it calculates the distance from the obstacles and it says the visually impaired people to move left, right or in front. Health monitoring module. In the health monitoring module, a heartbeat sensor is placed and the heartbeat of the visually impaired people is monitored continuously and the data is sent to the Firebase cloud and the cloud retrieves the information and the information is passed to the Android Studio. GPS monitoring. A GPS module is placed in the project to track the location of the visually impaired people. That is, the latitude and longitude coordinates of the visually impaired people are fetched to the Firebase cloud and the data is sent to the Android app. In the Android application, there are two modules. One is the heartbeat monitoring module, which keeps on updating the heartbeat that are collected from the stick and sent to the Firebase, and the location module keeps on track of the latitude and longitude coordinates of the visually impaired person. In case of emergency, the visually impaired person have to press the button and the alert message will be sent to the GSM, sent to the neighbors or caretakers who have the application using the GSM module. These are the comparison of various object detection modules we used. We have proposed using the YOLO model and the accuracy for the YOLO model is 97.7562, which is much faster than the other models we have used, that is fast RCNN, SSD, RCNN, etc. And the precision recall F score is also greater than the other three models. This is the comparison graph of the object detection modules. The comparison results we have obtained from the objects are for person it is more accurate, that is it calculates the 99% accurate results for every object. This is for each algorithms we have used for object detection. The MobileNet V2 algorithm provided the greatest accuracy with more than 98%. So we have used MobileNet V2 algorithm for object detections. This is the hardware